Yeah, so also for me, thank you very much for being here today. It's great to see you all and having us here. So, yeah, real time architecture for connected products in automotive. The motivation here was the EU Data Act. We had a client who reached out to us and asked, like, hey, this EU Data Act, it kind of looks scary. Don't you want to have a look at it? And so that is the motivation for what we call the streaming service internally and what my amazing team helped me to build. And we would like to introduce some part of it today so that you get an understanding of how can it be done, and what learnings did we had, what did we choose. And of course, afterwards, we are more than happy to give you more insights, live demos, and just chit chat with you. So maybe just shortly, the EU Data Act is a law designed to enhance the EU data economy and foster a competitive data market by making data more accessible, more usable, and encourage data-driven innovation and increasing data availability. To achieve this, the Data Act ensures fairness in allocation, the value of the data amongst the actors in the data economy, and it clarifies who can use what and under what conditions. So that was a quote we took out from all of these readings. A little bit hard, but thanks for bearing with me. So, an overview in a little bit shorter terms. We want to increase fairness and transparency of data availability. All when we say data, we mean all raw and pre-processed data. Means whatever is being collected in that very form of a product, a connected product, that is being affected. It is applicable since the 12th of September, so last week. Means until last week we didn't know if that is going to be a successful story or a very short, a sad story. Yeah, it kind of looks good so far, and but that's also the reason we might not have great numbers later to show. So yeah, consequences if we did not do this were high fines. The EU Data Act or any EU regulation can be quite harsh if you don't fulfill it. So we were very eager to make this deadline. Major interactions for the EU Data Act. So we speak here about three use cases. There's the B2C use case, the business to end customer. There's the business to business use case and the business to government use case. The business to customer use case, probably the one which affects anyone in this room in any kind of connected product, is where you as a user are the data recipient and the business, which product you are using, are the data holder. This entire use case needs to be free, so no charge of money here. This is the big difference between the B2C and the B2B case. The business to business case can be monetized. So there is a contract between a customer and a third party where consent is given that the collected data can be used by a third party. The business to government, this is a scenario where the government has the possibility and the right in some kind of emergency to access live data or access the data from any individual. Yeah, a couple of further listed major points is the unfair contractual terms, which is excluding non-negotiable terms. It means that we want to protect smaller businesses or consumers from like big forced contracts by larger companies. So making everything a little bit more fair. We want to protect the data being accessed by other countries or other governments to make sure the data is safe. Switching between data processing services should be possible, so we don't want to be locked in a given vendor. And also, data should be able to flow between data spaces. Means multiple services, for example, throughout borders. And of course, there's also an enforcement to this. Authorities needs to be able to monitor this and react. So what do we want to do? In a nutshell, actually, is we want to collect data from our product, connected products in some kind of data center or wherever in the cloud. And then this data should be accessible in real time. Sounds easy. In a nutshell, it's 3 points. Again, as we just covered, there are 3 different use cases. There is the business to user use case, the business to business, and the business to government. So this is where things get a little bit more complicated. There was a lot now to the EU Data Act, but in general, what do we want to do or what have we done? So the B2C and the B2B use case is where we focus on. So streaming real-time vehicle data. We wanted to influence the architecture and also the implementation. So most of this, or part of this, let's say, was moved to our team. For the entire EU Data Act, you need more than just a developing team. There's a governance team, there are legal teams, so there's a lot of teams getting together. For our part, it was the streaming part, and this is what we've done. The first release, again, from last week, was only to focus on compliance and make sure no one gets sued. And that is the most important part here. I think I can only give to any engineer. We do not give any legal advices. We are not lawyers. We don't do this. We are more than happy to look into some text and say what we think about it. But at the end, it's a team of lawyers who should make the calls and not us. A short summary of what happened. We started in January 2024 with a new team at this client, and it was originally a maintenance team, a lot of legacy tasks, migration, but overall it was a different focus. In April last year, the first EU Data Act conversation happened. We had the first readings, and we did the first, let's say, we got a little bit warm with that, and we had only one pair working on this. So not just did we have not enough time, but also we didn't have, as usual, the capacity which is needed. Followed up in November last year by a POC, which got us excited, and the client. In January this year, we were able to showcase the MVP, and by the beginning of this year, the major part of our team moved actually to the streaming service, while one colleague was maintaining 4 other applications alone just to keep us safe. In July, then we went to production. That was the first time we received data from like the real world. And this is a major point later on. This is something which was underestimated. And so we started scaling like crazy to kind of manage all of this huge data set. And yeah, last week, as mentioned, was go live. We are nervous and we create these slides. So that's also the reason why we're looking down a little bit. One last point before we get to the really fun part is what was already available. As mentioned in the beginning, the EU Data Act is 2 parts. There is the historical part of data, so you can access your data in the past, and there is the real-time streaming part. The real-time streaming part, this is what we did. The historical part was already there. So what the client was able already to do is to offer a download capability to download an archive. This archive takes a lot of time to be prepared. Then it's limited to 1 time a day. It's a heavy load on many systems. And it does not really fulfill the fair part of the EU Data Act. So this is why, let's say, it was not really, the client wasn't able to just step up the amount of downloads or something. So to fulfill the EU Data Act, there must have come a new solution. And this new solution is the real-time architecture from my team, and my colleague Dima is going to talk more about this. Please.
Fine. You can go on.
Absolutely fine. Go ahead.
So, but right now let's move on to the really interesting part. So, and then the key characteristic of our solution that first of all, we provide streaming data processing. Then second, the data set can be reconfigured at right time and then without interrupting the stream. So, and because of the streaming nature, data is partial to the customer as soon as we get it. So, and then third, user is in control of the data. So for example, the user can even get credential to a third party to process data for its user or withdraw it. And finally, there is a mechanism for sharing data between business and third party, but only with user consent. And out of this, we get main architecture requirement, and as usual, they can be split into functional, non-functional. So on the functional side, it can be we need to support both individual users and business customers. We should provide analytical on the user activity, or for B2B, things like billing mechanism, for example, counting the number of active machines, cars per customer per month, for example. And then we need to allow user to give withdraw or consent for processing the data. And of course, we only deliver the data the user selected, not everything we collect. For non-functional requirement, its communication protocol should be lightweight because basically we don't know how many users we'll have, so one or maybe many thousands. And connection between the user and the message broker must be secure. So the standard in the company, it's Auto2, and it should be compatible with existing IDPs. And also, of course, we need to scale if a load grows, then it should be cloud native solution. And it's maybe kind of wish or maybe dream. It's should be not legacy, but greenfield solution. And also these non-functional requirements dictate the infrastructure. So since it has to be cloud native, everything is deployed in AWS Kubernetes. Also, we use Terraform for creating AWS roles, permissions, database configs, and so on. So also deployments are handled via GitHub Actions, and we get external data from streams through Kinesis, but internally we use Kafka, both compacted topics and regular ones. And users or business upload their streaming configurations through a REST service. And since we wanted a lightweight communication protocol, we picked MQTT. We have been considering WebSockets and long polling, but that would mean that we have to letting the broker manage connections ourselves, and instead of letting the broker handle it. So especially it will be even more difficult if you had multi-node setup and for our handmade broker, and we would need to know to which node we should send data, for example, from filtering service to match the customer with the producer. So we can go into deep a little bit later. So like in abstract terms, the flow looks like this. Okay. Here's the data, here's a filter. We filter only what the selected attributes from the user, and then we send it to broker, and then to user. But before filtering happens, we need a configuration actually from the user. So this is one, to know what exactly the user wants. Then on the side, there's also a shiny, lonely hanging tracker service that monitors all services and records how user interact with the broker. So now we can look at the service in more details, and starting with the first one, the user interact with. It's a configuration manager. The main job here is simple. When the user selects which data they want to in the front end, we save that configuration for later filtering, as I showed before. They can also delete it if it's no need for it, or maybe replace it with a new one. So maybe new configuration or new attributes needed. So another responsibility is handling demapping events. For example, if the user sells the car, we should stop sending data for this car to this user. And in B2B context, it's when a customer withdraws the consent for a third party to process their data. And both case generates, in our terms, it's event to delete this saved configuration. So basically, configs have two states. They create it and delete it, and we store them in a Kafka compacted topic. So you can see these arrows going from the service to Kafka. So on the other side, we have the data coming from the upstream system. So, and for every incoming message, we do lookup in DynamoDB. If we find a match, we intersect the user's selected attribute with the ones from the event. And for each matching attribute, we generate a separate message for the broker. And in the config, we kind of define the route for this message. So we do combination of the user ID and the bin. So then the user can easily find only dedicated topic for this, for himself or herself. So, and with our data from the previous service, we are arriving in the streaming broker. And actually, it's, I think, maybe the crucial part. So, because it's a public facing, and actually it routes the message from the filtering service to the user, to appropriate user. It also manages connections. So that we should allow only one connection per user, because we just don't want to overload. So with the same connections, like if some user can create million connections for the same data, it can be easily overload. And for this, we choose RabbitMQ as the broker with MQTT plugin enabled. And to get internal broker events, we use the event exchange plugin that gives us messages like internal user created or deleted this, or successful or failed logins, or whether a stream has started or not. And the last key component is the activity tracker. Its job is to monitor the state of configuration and update is based on actually happening with the user data consumption. So the main consumer or like user, it's a L2 support. So the quality and completeness of this data from the service directly impacts how much sleep we can get during on all course shifts. So because if the user has some problem with connectivity, then we call us. Then it's bad sleep for us. Here we consume events from two topics. One topic is with information about configs, and the second one is with information about user activity that was produced by streaming and broker. So, and now we can put all pieces together into one more or less complete picture. So the flow is like a user or business connects through the portal or the backend to our private gateway and configure the setup in configuration manager. That configs get written into Kafka compacted topic, so we always save the latest version, but not the full history. From AWS SQS, so it's the arrow above, we receive demapping events, so also in the same series. For each one, we check if there is a config for that user car. If so, not, mark it, delete it, and push it to Kafka. The third part of interaction, this is L2 support that mostly consumes the data from activity tracker, which itself gets also, as I said, updates from Kafka. So the next relatively independent part is filter service, which pulls data from Kinesis and filters data that we want to send for them. And then appears like our streaming broker. For now, it doesn't have any connections with any services because we don't have any active connection with user or with business. And then when magic happens and someone decides to connect finally and receive data and check so what is it EU data actually is, like some other systems also appears in this diagram. Like first of all, we need to generate event. Let RabbitMQ generate events that, okay, so we have connection. This event is written to queue, and then we consume this event, transform to our activity events, and put data into Kafka, as I previously said, and we send it to activity tracker. And after all, as we mark this configuration, okay, we really started consumption for this configuration, we can start sending data from filter service to RabbitMQ and from RabbitMQ actually to the users. Yeah. And again, it's your time to shine.
Thank you very much. Appreciate it. So, showtime. Sadly, no, I can't show it to you. The thing with Automotive is, of course, in production, you need a vehicle. I don't have one, but others do. And while I try to track them, they don't really drive that often. I have the permission to do this, but this is how it might look like. You see, we receive data every 2 to 3 minutes for vehicles which are moving. I had to cut away a lot so that you get too many insights, but I think it's clear to see what's happening. We have timestamp, we have the selected attributes of the customer, so the customer opt in for some of these attributes, and every 3 minutes they will receive this data when there is data, of course. As soon as possible they will get this. That was a short time. I'm sorry. If you are interested in this, I'm happy to show it later to you again, but I can't stand here for 6 minutes and hope that someone is moving. Challenges and learnings. So I think here we have just a couple of points. Let me see the time. Okay, we're good. So what did we learn over the time? Right, we learned to ensure that we have automation in place and fast automation. Listen to your team. If they say the pipeline is too slow, they're probably right. Because when I had to look into this, I immediately did the changes, and then everyone was happy. Yeah, building, testing, deploying, Terraform, any kind of metrics, monitoring, all of these, secret rotation, all of these should be automated as soon as possible. The problem is there's a lot of things in your head which your team doesn't know about, and then they get frustrated and you become actually the bottleneck. So don't do this, automate this so it's easier for them. As Dima had mentioned, we had no estimations on actually how many users to expect with third parties. Now, if you don't know any numbers, you cannot build the right solution. So you can only overestimate or underestimate. So we built a scalable solution, and we hope one day we have so many users that we're happy and proud, and we don't think like we throw too much money out of the window. An application needs to be integrated, right? We said we're doing the streaming service. You saw the configuration manager, which is here a crucial part because it connects our world with end customers and the third parties. So these teams, they also need time. So make sure that they get access to your APIs as soon as possible. Make sure that they can already start and just like, be fast. Support and billing capabilities. These can become tricky. The B2B case is able to be monetized, and if there is a cash flow, then a lot of parties are interested in it, and there's a lot of good insights, and it will take you really long time to find a solution where everyone is happy with. So the billing part here, and of course the support part, these are two topics which might take you months just to talk with the right stakeholders and get finally something approved. A new application in a complex company was a challenge, at least for us. Again, we came in as a maintenance team, so legacy systems. Instead, now we had to come up with a greenfield project from the start without any support from like an internal architect, which means a lot of topics are just popping up you haven't thought about. They just pop up, and it's like your POs coming around. You're like, hey, have you thought about this topic? And no, we have not. Of course, we didn't know that we have to do this. So besides of actually building the application, you start worrying about a lot of different topics. So just keep that in mind. It will take a lot of time when you're on this. Next, a little bit to RabbitMQ. We choose RabbitMQ. It's a lightweight solution, and we liked it. So there is a couple of points. First, if using OAuth2, RabbitMQ offers this so-called scope to permission translation. So what's happening is that the OAuth token, the ID token, will contain a custom claim. This custom claim will define the permission of that user. So this needs to be communicated with the different IDPs you might face, because in our case we are not the IDPs; they are centralized IDPs, and getting them to agree on this, that you really need this and it needs to look like this, that will be a long journey. It gets even more complicated if you have more than one IDP. Things get really ugly there, especially in case of multiple IDPs, if the audience field isn't a constant. If you want to know more about this, more happy to share later more. Contributing in RabbitMQ is open source. So we also thought about, if we need something, we can contribute. No, we can't. It's written in Erlang, and we didn't have the time to learn it, but maybe one day we can do this. So far, we had just a very small contribution, and it had to do something with Kubernetes. So also there, not Erlang. Production deployment of RabbitMQ. We choose RabbitMQ also because Amazon MQ actually offers RabbitMQ. So it was like, good, we have a managed RabbitMQ instance, so we don't have to think about scaling. Sadly, the mentioned plugins by Dima, they were not supported, so we had to find a different solution, and now we are deploying RabbitMQ in a 3-node setup ourselves. So that's also something to look out for in case you need MQTT. Unknown missing capabilities for easy looking problems. One of this was proxy protocol v2. Right? We want to know the IP addresses of the actual customer and not the one from the load balancer. My sentence, it works in my own load balancer. That does not count because my own load balancer is not in a chain of a lot of things happening. So that took quite some time. Proxy protocol v2 enabled for RabbitMQ means it needs to happen everywhere. And things we have not shown here is, for example, the connection between the filtering service and RabbitMQ. There's actually something in between. It's HA proxy just to fulfill these things. And now I'll come to the huge load of incoming data. And I would skip this slide and go immediately to the next one so something gets clear. We see here 2 charts. One of them is actually production and the other one is the non-production part. We, of course, while developing, we focus on non-production, right? And we thought there's some kind of magnitude between non-production and production, but it's not. So in non-production, we had about 14,000 messages. I think these are 20-minute steps. And so we had like a 2% load of 1 Kinesis shard. We went to production and ended up with 250 shards. Because it now went to 14 million or 30 million messages. And handling this was really not easy. So my advice here, go to prod as soon as possible and don't assume that things will work out. Reduce the noise. We have the gray bars, for example, at the top are unparsed events we have internally. So there's a lot of things happening, a lot of noise on many places. Which will take processing time. And once the application is running, go revisit it and make sure that you can just focus on what is really necessary. The same goes for the next one, the queue events incoming. You see a lot of green bars here, which are incoming SQS events, but actually we just needed 5 of them. So also here, a bit see what you can save. Next, learn about your costs. You will create costs at many places you were not really aware of until someone comes and tells you like, hey, does your team have a lot of money? No, please change this. This goes for logs. In Kibana, right? It's just like, okay, I think it's very clear when we went to production, it is the first big green bar. And then you can also tell when my PO received the email. The same goes also for Datadog. So also here, these were ingested spans for RPM. And this is, I think, a magnitude of like 400 million down to a couple of thousand. So the line's actually there, you just can't see it. Also this, someone else had to first tell us. So that wasn't so pleasure. Tech stack, again, happy to talk about this in more detail. But as you can see, majority here is AWS with everything you would expect from this talk: Scala, RabbitMQ, Kibana, Kong, Terraform, GitHub Actions. I don't want to take too much of your time. Now, the last 2 steps, slides, is that the correct one? Yes. Steps to take so you can prepare for such an engagement. First, you are a bit late, but better starting late than never. Get familiar with the EU Data Act, talk with the respective governance teams, take the time it needs to understand the requirements, push the client for answers because it will take some time, have cross-functional workshops, understand the amplitude of data, especially the incoming live data in this example, start early with authentication and authorization. This will take time. And provide feedback in general. So I think the time is probably up. So the last thing I want to say is a big thank you, of course, to everyone in this room. But I would also like to thank my team, who sadly today is not here, but I wanted to mention and at least showcase them here. So we had a great team of wonderful people who supported us. Our PO, I can't tell who it is, but he likes Dragon Ball. So this time he is Son Goku. And also a big thanks to Alem, who pushed me and us to be here today and get this done, and to all of you here in the audience.